Hi guys, welcome to my channel. In this video, I will be covering complete Unit 3 in Cloud Computing subject. I will explain each and every topic in detail, and whatever the topics that I am going to cover in this video, I will provide all those topics and the timings in description. Before starting this video, please check in description. I will provide this Unit 3 handwritten notes in description. You can download from description. Guys, I have uploaded complete Cloud Computing subject tutorials. I will provide that link in description. You can watch from there. If you are watching this video for the first time, don't forget to like, share and subscribe to my channel. Let's get started. At first, I will explain what is cloud architecture. Guys, each and every technology has structure, and we call the structure as architecture. By seeing architecture, we can clearly know how the technology will work. In same way, cloud also has an architecture. By seeing cloud architecture, we can clearly know how cloud functions. As we know, cloud depends on internet to work. Guys, cloud architecture has 4 layers. By seeing that 4 layers, we can clearly know how user access and use the cloud. Guys, these are 4 layers in cloud architecture. And the first one is user or client layer. Second one is network layer. Third one is cloud management layer. And fourth one is hardware resource layer. I will explain each layer in detail. At first, I will explain user or client layer. Guys, this is lowest layer in cloud architecture. This layer includes users or clients who use the cloud. Guys, in user or client layer, users will use devices like thin client, thick client, mobile phones or tablets. Thin clients need help from the other systems to work properly. I will give an example. For example, there is software company. In the software company, there are so many systems, and all the systems are low configuration systems. If the systems want to do any work, then they need to connect to server to complete that work. Guys, for example, this computer want to use one software. In order to use that software, this computer must connect to server. For example, this computer want to store files, but this computer is low configuration system. This computer cannot store large size files. So in order to store large size files, they need to store them in server. So again, this computer need to connect to server in order to store large size files. As all these computers are low configuration computers, these computers need to connect to server in order to do any work. So we call these computers as thin clients. Thin clients are the computers that depends on other computers to work. Second one is thick clients. Thick clients work on its own like a regular computer. I'll give an example. Because for example, there is software company. In this software company, all computers are high configuration computers. All computers can work on their own without depending on server. So we call these computers as thick clients. Third one is mobile phones or tablets. Guys, even by using handheld devices like smartphones or iPads, we can use cloud. This is the example. For example, if you consider YouTube or Google Drive, these are cloud applications. We can use them in mobile or tablets. So user or client layer contains 3 types of users. They are thin clients, thick clients, and mobile phones or tablets. Thin clients depends on other computers to use cloud. And whereas thick clients can use cloud on their own, and even by using mobile phones or tablets, we can use cloud. This is all about user or client layer. Second layer is network layer. Guys, by using network layer, users can connect to the cloud. This connection is usually the internet for public clouds or local area network for private clouds. Guys, for example, if you consider AWS and Google Drive, anyone can use them by using internet. So we call Google Drive and AWS as public clouds because anyone can use them by using internet. Data center is nothing but where company servers are stored physically. We call that place as data center. As I am using Google Drive, but we don't know where Google data center is located. It is hidden. So we use Google or Amazon services which are available worldwide, but we don't know where the cloud data center is located. It is hidden. This is example of private cloud. For example, there is software company. This software company will purchase so many servers for this company, and only employees in this company can use these servers, and we call this as private cloud. All these devices, computers and servers are connected to each other through local area network. For example, if you consider Google Drive and AWS, both are public clouds because anyone can use them by using internet. And whereas if you consider the servers, only employees in this company can use the servers. Outside people cannot use the servers. So we call this setup as private cloud. And all these devices are connected to each other by using local area network. This is example of private cloud. A company may use its own cloud only within its office building or organization. Some companies may use their own cloud within office building. If you want to use any cloud service, you need a good network. That is nothing but you need a fast internet connection. Guys, if your internet is slow, it is not cloud provider fault. It is your fault. Guys, for example, if you watch any video in YouTube, if your internet is slow, then it will keep on buffering. And it is your fault because your internet is slow. It is not YouTube company fault. So by using network layer, users can connect to cloud. By using internet, we can connect to public clouds. And whereas by using local area network, we can connect to private clouds. This is all about network layer. Next, I will explain what is cloud management layer. Guys, cloud management layer contains softwares. By using these softwares, we can manage and control cloud operations. Basically, there are two types of softwares in cloud management layer. And the first one is cloud operating systems. And second one is management softwares. Guys, if you want to play games or if you want to watch movies or softwares, at first you need to install an operating system in your computer. In same way, even in cloud, if you want to use cloud resources like servers, softwares, storage, etc., at first you need to install an operating system in your cloud. By using cloud operating system, we can connect to cloud resources like server, storage, etc. Cloud operating systems are the special softwares that connect the user to the cloud resources like servers, storage and data. Same like installing Windows operating system in our computer, even in cloud, we need to install cloud operating system in order to use cloud resources. Second one is management software. By using management software, we can manage cloud resources. By using management software, we can do scheduling, optimizing and organizing workloads. Scheduling is nothing but deciding at what time and how task must run. And optimizing means using cloud resources like servers and storage efficiently. That is nothing but based on our requirement, we can increase servers and we can decrease servers. And based on our requirement, we can increase storage and as well as we can decrease storage. We can optimize resources based on our need. And third one is organizing workloads. By using management software, we can manage tasks and work happening in the cloud. And this cloud management layer directly affects service level agreements. Guys, service level agreements are the agreements between user and cloud providers. Guys, in service level agreement, cloud providers will guarantee three things. They are performance, speed and availability. Performance is nothing but cloud providers will say cloud will work fast. And speed is nothing but whenever you want to use any service in cloud, that service will be available to you without any delay. And availability is nothing but all cloud resources are available whenever you need them. And if something goes wrong, cloud provider must pay penalty for breaking the agreement. Guys, AWS and Microsoft Azure, these both are examples of public cloud, and OpenStack and Eucalyptus, these both are examples of private cloud. And fourth one is hardware resource layer. The name itself says hardware resource layer. This layer includes hardware resources that power the cloud. Guys, many users will use AWS cloud and Google cloud. And AWS company contains so many servers and similarly Google company also contains so many servers. And place where servers are stored physically, we call that location as data center. So AWS company contains so many data centers. Data center is nothing but place where servers are stored physically. We call that location as data center. Whenever user upload any data in cloud, the data is stored in data centers. So data centers are large buildings full of servers and hardware where cloud data is stored and processed. Guys, AWS and Google both are public clouds because anyone can use them by using internet. And in public clouds, data centers are managed by cloud providers. So AWS and Google are cloud providers. They will manage data centers. And some software companies will create their own servers, and their servers are accessed only by employees in that company. Outside people cannot access their servers. So we call it as private cloud. In private cloud, data centers are managed by company itself. So hardware resource layer is all about hardware resources. Hardware resources are stored in data centers. This layer is the most critical for service level agreements because it ensures that resources are delivered quickly and reliably. The service level agreement completely depends on data centers because if anything happens to data centers, all users cannot use cloud. So data centers must work 24/7 without any problem. Only if they work properly, all users can use cloud. So hardware resource layer is very important in service level agreement. Guys, if there is any delay or failure in cloud service, then cloud provider must pay penalty as per service level agreement. And data centers are connected with high speed networks and they will use efficient systems in order to transfer data. Sometimes multiple clouds share the same data center or a single cloud may use several data centers. I'll give example. For example, if you consider AWS cloud, in AWS, some data centers are located in Hyderabad, some data centers are located in Bangalore, and some data centers are located in Delhi. Multiple users can use same data center or single user can store data in different data centers. So sometimes multiple users will use same data center or single user will use several data centers. Next I will explain anatomy of the cloud. Guys, anatomy is nothing but basic parts that make up the cloud. We call it as cloud anatomy. These are 5 parts that make up the cloud, and the first one is application, second one is platform, third one is infrastructure, fourth one is virtualization, and fifth one is server or storage or data center. I will explain each of them. And the first one is application. Guys, we will run so many applications in cloud. So this application layer is top layer where our apps will run. For example, we will run apps like Google Docs, Zoom, Gmail, etc. in cloud. And second one is platform. Guys, if you want to run any applications in cloud, at first you need to install operating system in our cloud. So platform is nothing but operating system. In cloud, we need to install operating systems like Windows or Linux. After installing operating system in our cloud, we can run applications. This is middle part that helps softwares run properly. This platform connects softwares to the hardware. Third one is infrastructure. Guys, infrastructure contains 3 parts. They are processing power, storage and network. Cloud must contain processing power in order to work. Similarly, cloud also needs storage in order to store data. And similarly, cloud also needs network in order to access internet. So cloud must contain these 3 things. And fourth one is virtualization. Guys, virtualization means creating virtual systems from real physical machines. Guys, virtualization means inside single physical computer, we can create multiple virtual computers. For example, if you consider cloud, in cloud, inside single physical server, we can create multiple virtual servers. Guys, for example, if you consider AWS, in AWS, single server is given to multiple users. For example, AWS company contains so many servers. And single server is given to multiple users. For example, in this single physical server, this person will create Windows virtual server, this person will create Linux virtual server, and this person will create Mac virtual server. And this person will do office work, this person will store some files, and this person will do office work. And all these virtual servers are independent. This person cannot see each data, and similarly this person cannot see each data. All are independent. So in cloud, one big server can be divided into smaller virtual servers that work like separate computers. This is all about virtualization. And fifth one is physical hardware. Guys, physical hardware is nothing but real hardware like server and storage. Because of server and storage, cloud will work. Guys, in cloud, physical hardwares are present in data centers. So in cloud, big computers and storage machines are placed in data centers. This is all about anatomy of cloud. Next I will explain network connectivity in cloud computing. Guys, by using cloud computing, we can use resources like servers and storage by using internet. So in cloud, people can run applications and they can get results. If you want to access cloud without any problem, then you need good internet speed and quality. Guys, by using cloud computing, we can use resources like servers and storage by using internet. So in cloud, people can run applications and they can get results. If you want to access cloud without any problem, then you need good internet speed and quality. Guys, there are different types of clouds and how the network is connected play a big role in how people access the cloud. The two main types of connections are public cloud and private cloud. Guys, for example, if you consider AWS and Google Drive, everyone can use AWS and Google Drive by using internet. So we call this AWS and Google Drive as public clouds because everyone can use them by using internet. Guys, some companies contain their own cloud network and only employees in that company can use that cloud. Outside people cannot use that cloud. And we call that cloud as private cloud because only employees in that company can use that cloud. Remaining people cannot use that cloud. So people can access cloud network by using two ways. One is public cloud access and second one is private cloud access. At first I will explain what is public cloud access. Guys, all users can connect to public cloud by using internet. Some public cloud providers also offer virtual private networks for safer connection. For example, if you consider AWS is public cloud. Inside public cloud, we can create virtual private network for safer connection. So some providers like AWS offer virtual private network for safer connections. Guys, everyone can use public cloud by using internet. So there will be security problem. So in order to keep our data safe, providers must use encrypted tunnels like security pathways in order to secure our data. But this process will slow down cloud connection. So in order to speed up the cloud, providers must choose better paths. For example, if provider use short route between cloud and user, then cloud connection will be fast. Guys, public clouds completely depends on internet to work. And these public clouds are managed by service providers. So provider must choose better path in order to send data quickly. Second one is private cloud access. Guys, some company creates their own cloud setup by using server, storage, hardware, software, etc. And we call this setup as private cloud because only employees in that company can use that cloud. Using cloud is nothing but using softwares, hardwares, server, storage, etc. And only employees in that company can use them. Private clouds are part of company's own network, so they are more secure and easy to control. Outside people cannot access private cloud, so data will be secure. Private clouds might use internal networks or VPNs for connecting users. Guys, internet is big network. Everyone can use internet. Inside big network, company will create one small network. We call this network as virtual private network or internal network. Only company employees can connect to this network. So if company already contains good network, they can easily move their data to private cloud. Still performance will be good. Next I will explain what is public intra-cloud networking. Guys, in public clouds, servers are located in company's location and we can use those servers by using internet and we cannot control these servers. Only cloud providers will control these servers. Still they are public clouds, our data will be secure. Guys, in service level agreements, cloud provider will promise that there will be security and resources will be always available to user. Providers will not break the service level agreement. Service level agreements are the agreements between user and cloud provider. In public clouds, resources like servers may be far apart but are connected through the internet. The connection between resources are managed by the cloud provider, so user don't see or control them. Will connect to servers by using internet and cloud providers will manage these servers. User cannot control them. In public clouds, security and access to the resources are very important. The cloud provider promises certain performance levels which are defined in agreement called service level agreements. Next I will explain what is private intra-cloud networking. Guys, in private cloud, companies contain their own data centers. Data centers are nothing but where servers are located physically. We call that place as data center. So complete company's data and internal applications are stored in company's data center. If the company's applications are built in small parts, the data has to move between these parts and the users. This increases the need for strong connections. Guys, I will give an example. For example, my company created a small application like Amazon. And this application is built in small parts. Like one part is user account, next part is payments, and next part is orders. By using user account, whenever user pay payment, immediately we need to place order. So all parts of this application must communicate between each other. And immediately whenever order is okay, we need to send feedback message to user. So if the company's applications are built in small parts, the data has to move between these parts and the users. In this case, we need strong network connection. Yes, for example, in private cloud, one part of application is placed in one server, next part is placed in another server, and next part is placed in another server. Guys, complete application performance depends on network connection. If connection between these resources and user is not good, then performance decreases. Application performance depends on how we build application and how we set up network. Next I will explain new facets in private networks. Guys, facets mean developments or challenges. Guys, long back, companies used to place their applications in their own servers. But present, many companies are placing their application in cloud by using service called software as a service. That is nothing but cloud will maintain our software. Software as a service means companies rent software over the internet instead of installing it in their office. Companies will place their software in internet and all users will access the software by using internet. Guys, older networks were designed in order to connect users to office servers, not to cloud-based tools. So if internet connection fails, people can't use softwares. That is nothing but if internet connection fails, business can't work. So networks must be like electricity. If network goes down, work stops. So companies need network that can handle old style tools and as well as new style tools. That is nothing but companies must create network. That network must connect to users to company's application. Even though if we place that application in office server or in cloud, that network must connect users to our application. Next I will explain path for internet traffic. Older network used only a few internet gateways. Few internet gateways are nothing but access points that connect the users to internet. Fewer gateways mean slow connection between user and cloud. So if we create more gateways in different locations, there will be fast connection between user and cloud. For example, if you consider some video calling applications like Skype, Zoom, etc., they will consume lot of internet data. So they need well-planned network. So in order to connect users to cloud, companies must create shortest and faster paths. Next I will explain applications on the cloud. Guys, we will use computer in order to run applications. For example, if you consider MS Office, calculator, Photoshop, all these are applications in computer. Applications are nothing but softwares. So without applications, there is no use of computer. So applications are what make a computer useful. Over time, different types of applications have been developed. Guys, at present there are so many applications developed. Mainly there are two types of applications. One is standalone applications and second one is web applications. I will explain each of them. Guys, standalone applications are the applications that do not depend on internet to work. For example, if you consider calculator software, in order to use calculator software in our computer, there is no need of internet. Just we can install calculator and we can use. Not only calculator, for example, if you consider MS Office Paint, in order to use these applications, there is no need of internet. So all these are examples of standalone applications. Standalone applications run on a single computer and do not need a network to work. That is nothing but without internet, these applications will work. They use only the resources of the machine they are installed on. That is nothing but our computer contains some drivers. Based on the drivers, our software will work. These applications are independent and do not need data or processing power from other systems. Guys, some computers will depend on other systems to run applications. But standalone applications run on a single computer without depending on other computers. Example, a basic calculator app installed on your computer. Second one is web applications. Guys, at present, user needs are very high. At present, so many different kinds of applications are created and many people are using that applications in internet. So applications which are accessed by using internet, we call that applications as web applications. And these web applications work based on client server model. Guys, applications are present in company server and users will access this application by using internet. And we call these users as clients. So server is a powerful machine where the web applications is installed and clients are the users who connects to server by using their devices using internet. One popular web application is Facebook. For example, if you consider Facebook, Facebook is installed in Facebook company server and many users will use Facebook by using internet from their devices. Guys, web applications are very popular, but they have some limitations. And the first one is not elastic. Guys, if too many people are using web application at the same time, like using Facebook at the same time, then that web application slow down or stop working because web applications cannot handle extra pressure. So web applications are not elastic. Second one is not multi-tenant. Guys, multiple users cannot use web application by using single device. So each user needs separate computer and he need to install web application software in that computer. For example, in order to use Facebook application, I need separate computer and I need to install Facebook application in the computer. So web applications are not multi-tenant. Third limitation is couldn't measure services from users. Guys, for some web applications, you need to pay money. Even though if you use or don't use that application, you need to pay money. And fourth one is worked on only one specific platform. Guys, some applications will work in one platform and will not work in other platforms. For example, one web application will work in Windows, but it will not work in Linux or Mac. Fifth limitation is didn't offer flexibility like pay as you go options. Guys, for some web applications, even though if you use or don't use that application, you need to pay complete money. So users had to pay for full service even if they didn't use it much. Guys, in order to overcome problems of web applications, cloud applications were introduced. So cloud applications are similar to web applications, but they are designed to overcome the limitations of traditional web applications. That is nothing but in order to overcome problems of web applications, cloud applications were introduced. We can place our software in cloud and we call that service as software as a service. These are features of cloud applications. Guys, for example, if you consider Facebook, Facebook is web application because all people will install Facebook software in their computer and they will use Facebook. And whatever photos and videos they share, the data is stored in Facebook server. Now my company developed the same application like Facebook, but instead of placing that application directly in internet, my company will place that application in cloud. So my company will develop one software and my company will place that software in cloud like AWS, Microsoft Azure, etc. Whenever my company places application in cloud, these are advantages. So these are features of cloud applications. And the first one is multi-tenancy. One application can serve many users at the same time. Each user feel like they have their own private version of the app, even though software is shared. Changes made for one user do not affect others. Guys, I will give an example so that you can clearly understand this definition. For example, my company developed one banking application. So whenever my company places application in cloud, single application is used by many people. Even though application is shared among multiple users, that application is like private application. Whenever this person opens banking app, he can see only his details, like his bank account number, his amount, his loans, etc. He cannot see remaining people account details. So online banking apps, where many users access the same app, but their accounts and data remain separate. This is example of multi-tenancy. That is nothing but multiple people can use single app at a time and all are independent. And second one is elasticity. Guys, whenever we place application in cloud based on users demand, we can modify cloud. For example, if many people are using our app at the same time, then we can add resources like we can increase servers, we can increase network bandwidth, etc. And if only few people are using our software, then we can decrease resources. So we can change cloud system automatically based on users demand. This is meaning of elasticity. As cloud support elasticity, even though there is high traffic, application performance will be good. And third one is heterogeneous cloud platforms. Guys, whenever user places application in cloud, users can access that application by using any device and by using any operating system like Windows, Linux, Mac, etc. And fourth one is quantitative measures. Guys, if you consider web applications, even though if you use or don't use that app, you need to pay money. But whereas if you consider cloud applications, how much time we use cloud applications, only for that we need to pay money. Cloud services are measurable. Users are charged based on what they use, how much time they use and what they use, only for that they need to pay money. Same like paying electricity bill and water bill based on what we use. And fifth one is on-demand services. Guys, whenever we want, we can use cloud applications. By using any device, at any time and from anywhere, we can use cloud applications. Just we need internet, that's it. So these are 5 features of cloud applications. In order to overcome problem of standalone applications, web applications were developed. And in order to overcome problem of web applications, cloud applications were introduced. Next I will explain managing the cloud. Cloud management means taking care of the cloud to ensure it works well and provide good quality services. Guys, if we take care of the cloud, then cloud will work well and it will provide good quality services to users. And cloud management is very important because the cloud success depends on how it is managed. Cloud management has two main parts. One is managing the cloud infrastructure and second one is managing the applications. Guys, we call these two as functions of cloud management. At first I will explain managing the cloud infrastructure. We also call it as infrastructure management. Guys, cloud infrastructure is like backbone to the cloud. If we don't manage it well, then entire cloud system will fail and user cannot use good quality services. That is why we need good infrastructure management. And good infrastructure management focus on resource management. Guys, cloud contain resources like server, storage, hardware, software, etc. And resource management means managing resources like server, storage and bandwidth. And resource management include tasks like scheduling, provisioning and load balancing. Scheduling means deciding which task will get resources and when. Guys, at particular time, based on task, we need to provide resources to user. This is meaning of scheduling. And provisioning means providing resources as needed. Whenever user need resource, we need to provide them. This is meaning of provisioning. Guys, no server in cloud must be overloaded. So load balancing means ensuring no server is overloaded. If server is overloaded, then server becomes slow and we cannot perform any operations on server. So good infrastructure management focus on resource management. Guys, if we don't manage cloud resources properly, then cloud performance will decrease and user may face slow or interrupted services. And functionality also decreases. That is nothing but basic features in the cloud may stop working. And if we don't manage resources properly, then cost also increases, making the cloud expensive for users and less profit to providers. That is why we need efficient resource management. And efficient resource management focus on performance. That means always keep the cloud systems running well. And second one is cost. Managing the cloud at low cost to attract more users. Guys, if cloud is less cost, then many users will use cloud. And third one is energy efficient. Use less power by techniques like server consolidation, which combines workloads onto few servers. Guys, we will not use all servers in cloud. So we can work with only fewer servers and we can turn off remaining servers. This is server consolidation. This technique will use less power. In cloud, we will use so many resources like server, storage, software, hardware, etc. And these resources are used by multiple users in cloud. That is why infrastructure management is important in infrastructure as a service. And second one is managing the cloud application. We also call it as application management. Guys, server is nothing but 24/7 working high configuration system. And cloud contains so many servers. And many software companies will keep their apps in cloud because cloud will be very fast. So company moves their apps to the cloud to become faster and meet changing needs. Guys, many of the companies will think that if they place their apps in cloud, then that apps will work fast. But keeping apps in cloud is complex because our app must depend on cloud storage and cloud databases, and also our app must depend on third-party tools like email or messaging services in cloud. So whenever companies place their app in cloud, then that app must completely depends on cloud. If there is any problem in cloud storage or database, then that app will stop working. These are challenges of managing cloud applications. So whenever any companies place their app in cloud, we must ensure that app must always work. That is nothing but app must be available to users. This is meaning of availability. And second one is monitoring the cloud infrastructure to support the apps. Guys, apps depends on resources like server, storage, hardware, software, etc. So monitoring cloud infrastructure is nothing but we need to monitor resources that are connected to our app. For example, my app is placed in server. If that server stops working, we cannot use app. So always monitor cloud infrastructure to support the app. Whenever we place our app in cloud, that app must be secure. No hacker must hack our app. So managing policies like security, governance and audits. So we need to manage all these things for cloud applications. These are solutions for managing cloud applications. And the first one is Use tools that monitor app performance and fix issues automatically, like increasing capacity or adding resources. As for example, I placed an app in one server, but memory is full. So cloud contains so many tools that will monitor our application, like it will monitor app performance and fix issues automatically. So whenever memory is full, automatically some tools will give alert messages. So based on that, we can immediately increase memory. So first solution is we need to use tools that monitor our application. And second one is collect the data to analyze and make improvement. Guys, whenever we place any application in cloud, we can collect complete information like how much memory that app is consuming, how many users are using that app. We can collect the complete data regarding that app and we can make improvements. So there are some programs in cloud that will manage our cloud applications. And managing the cloud infrastructure means managing physical and technical systems that run the cloud. That is nothing but we need to manage resources like server, storage, etc. that run the cloud. This is all about managing the cloud. That is nothing but cloud management. Next I will explain migrating application to cloud. Cloud migration means moving your software and data from your current system to a cloud-based system. I'll give an example. Guys, for example, let us say you have one software company. In your software company, there are some servers. In that servers, complete data is stored. Now you want to move your complete data from servers to cloud, like AWS. So cloud migration means moving your software and data from your current system to cloud-based system. This is meaning of cloud migration. Guys, these are phases of cloud migration. And the first one is evaluation. Evaluation means checking your current setup. Guys, at first you need to check how many softwares and how much data your servers contain. And also you need to check how much cost it will take in order to move your data from servers to cloud. If it takes more cost to maintain your data in cloud, then there is no use. Only if it is worthy moving your data to cloud, you need to move data. So look at what you have now, your software, storage and cost. Check if it is safe and worthy moving to cloud. This is meaning of evaluation. Second phase is migration strategy. That means plan to move your data from current system to cloud. That means either you will move complete data to cloud or you will move only some part of data to cloud. You need to plan that. You can move everything at once or move only one part at a time. And third one is prototyping. That means you need to do small test. Guys, at first you need to move only some part of data to cloud. If the data is working well, then you can move everything to cloud. Test a small part of your system on the cloud to make sure everything works well. And fourth one is provisioning. That is nothing but set up the cloud. Guys, provisioning means prepare the cloud by installing your softwares and copying your data. Make sure everything connects and works smoothly. Guys, after installing each and every software in cloud and after copying complete data in cloud, you need to make sure everything works well. And fifth one is testing. This is final check. Guys, after moving complete data to cloud, you need to check whether cloud system is working well or not. You need to check whether cloud system can handle many users, problems and heavy work. These are phases of cloud migration. Next I will explain approaches for cloud migration. Thus approaches mean various ways to move your software and data from present computer to cloud. Our first approach is migrating existing applications. That means update and re-architect current applications to run on the cloud. Guys, whenever you transfer your data from present system to cloud, some applications may not run properly. At that time, you need to update that application or you need to redesign that application in order to run properly. This is meaning of migrating existing applications. And second one is start from scratch. Guys, whenever you move applications to cloud, some applications may not work entirely. At that time, you need to create new applications from starting. Build entirely new applications designed specifically for cloud. If any applications don't work in cloud, then you need to create new applications for cloud. For example, let us say I created one teaching app that is working in my system. But whenever I move that application to cloud, it is not working. So at that time, I need to create new application that will work on the cloud. And third one is separate company. Guys, whenever you transfer data from present system to cloud, you need to hire new employees. That employees will perform various operations on the cloud. So create a new team or company dedicated to the cloud operations for better focus. And fourth one is buy an existing cloud vendor. Guys, cloud vendors are the companies that provide cloud services. For example, if you consider AWS, AWS is cloud vendor because it will provide cloud services. Whenever I place my company's data in AWS, that AWS company will maintain my data. It is AWS company's responsibility.